right, guys, 3B. 3B was a hard one. So here's what I wanted you to realize first. Look at your outputs. Usually my outputs are growing bigger. These 10, 8, 6, 4, 2 are growing smaller, which means whatever the number is that I have to multiply by x, it's negative. So we've got to figure out what negative number to multiply x by, and then when we have to add or subtract to get the other number. Well, let's see. Let's come up with a couple different rules for 0 and 10, and then we'll check them to see if they work for everything else. To get from 0 to 10, I could take x and multiply it by -1. -1 times 0 is 0. I'd have to add 10. If I put in a 0 here, 0 times -1 is 0. I'd have to add 10 to get this 10. If I multiplied it by -2, and I plugged in a 0, well, if I plugged in a 0, I'd have to add 10 again. 0 times -2 is 0 plus 10. If I plugged in a -3, I'd have to plug in 0 again and plus 10. What's the same about all of these? No, right, no matter what negative number you multiply by, you're going to have to add 10 at the end. So let's see if one of these works. Let's put in a 2 and see if we get out an 8. So let's take this one and put in a 2. In your calculator, do -1 times 2 plus 10. What do you get out? 8. Okay, so you put in a 2, you got out an 8. Let's try it with the next one. Let's try putting in a 4, and let's see if we get out a 6. If we put in a 4, -1 times 4 is -4, plus 10, so we got out a 6. So it worked for this one, this one, and this one. Let's double check one more time. If I put in a 6, I'm hoping to get out a 4. -1 times 6 is -6, plus 10, I pop out a 4. So it works every time. So my rule is y equals -1x plus 10. I know that's a hard one, but realize that when the output is going down, that number you have to multiply x by, or the input by, is going to be negative. All right, the sequence is shown in the picture form. Assume the sequence continues to grow in the same way. Organize the information for the figures into an input-output table. Well, my input is the figure number. My figure numbers are 1, 2, 3, and 4. 1, 2, 3, and 4. The number of dots in figure 1 is 2. The number of dots in figure 2 is 1, 2, 3, 4, 5, 6. The number of dots in figure 3 is 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. And the number of dots in figure 4 is 14. Well, we can use that little trick that I showed you guys because look, my inputs are all nice and neat in order. 1, 2, 3, 4. Up here, my inputs weren't in order. 1, 2, 5, 7, 10. That doesn't make sense. 0, 2, 4, 6, 8. I'm skipping 1, 3, and 5. These are nice and neat in order. So we can use this, the fact that I have to add 4 each time, to help me. If these are in order, and these go up by the same amount, I can take this number and use that to multiply. So I know I'm going to take my input, and you know it's going to be D equals my input. I know I'm going to times it by 4. Now if I do 1 times 4, I'd have to subtract 2 to get to 2. Let's see if it works for all of them. 2 times 4 is 8. Subtract 2 would be 6. 3 times 4 is 12. Subtract 2 would be 10. 4 times 4 is 16. Minus 2 is 14. So we're taking our input, multiplying by 4, and then subtracting 2. Your input here is n. We need to write this correctly, and so you get D equals 4n minus 2, which means the number of dots in your figure is always the figure number times 4 minus 2. All right, next one. Are these equivalent? Absolutely. If this guy jumps over the fence, it becomes 3 times x is 3x. 3 times 4 is positive 12. And that's called the distributive property. 10 minus 2x and negative 2x plus 10. Let me use a side paper for this. So 10 minus 2x and negative 2x plus 10. Well, the only way I know to be able to do this is, this is addition, so I know I can switch these and still have the same thing. So 10 plus negative 2x. This and this are the same, so let's see if this. I can change this to plus a negative, and look, same thing. So yes, they are equivalent because I can change minus signs into plus a negative. All right, let's try this one. So negative 6 parentheses x plus 5 and negative 6x plus 5. Let's see, this guy's got to jump the fence. So negative 6 times x is negative 6x. Bring down your plus sign. Negative 6 times positive 5 is negative 30. Could that and that be the same? No. No. Because the negative 6 has to multiply by the 5 as well. That negative 6 has to multiply by the 5 as well. They did the negative 6 times x, but here they forgot that the negative 6 needs to jump over and hit the 5 as well. And last one, 4x and 2x plus 2. Well, I can't add 2x plus 2. Remember, it's like adding apples and bananas. I have 4 apples plus 4 bananas. If I add them together, I have 8 banapples? No. They won't add together. So no, cannot be simplified. All right, let's see if we can squeeze one more into this one. And we can't. I'll do 6 on the next one.